Welcome back to Easy Gates Electrical Gate 22 paper solutions. Next problem based on electric circuits, problem number 55 as per the master question paper. So that's a problem using dependent sources, a dependent voltage source, a dependent current source, and one independent voltage source. In the given circuit, the magnitude of the voltage V1 in volts. So it's talking about only the magnitude. That means even though if its sign is negative, you need not to worry about it. So the magnitude of voltage V1 in volts across the 8 kilo ohm resistor is round off to the nearest integer. Okay. So that's a problem. Yes, how to approach the problem. So there is a voltage dependent voltage source and voltage dependent voltage source, and there is a current dependent current source. You can call it as a voltage control voltage source also and current control current source also. That's fine. Okay, so now let me help myself by taking the bottom as a reference. So taking this as 0 volt, and this point is known to be 75 volts. And since it is 0, this is also going to be 0. If that is the case, this point will be equal to 0 volt. That means this point is going to be, assuming potential rises by V1, this point will be V1. Okay, so therefore I can say the current I is equal to, so V1 is falling across 8K. So I can write one equation as V1 by 8 kilo ohms. I is equal to V1 by 8 kilo ohms. One equation possible. Another equation, how to make another equation means, yes. So what is the current I? You can also play for the KCL, but is it really required? We'll check. So then one equation is ready. There are two unknowns. One is V1, another one is I, but problem is we need to find out what V1. So this is, let it be the equation number 1. Let me go for one more equation. If this is 0 volt, this voltage is going to become 0.5 times V1 because potential rises by 0.5 V1. So this is 0.5 V1 and this is 75. So therefore the drop across this will be, assuming this is higher, this is lower, I can write another equation. I is equal to 75 volts minus 0.5 times V1 divided by 2 kilo ohms. That's another equation. Okay. You can also write a KVL for this. That is also going to give such an equation. I into 2K is equal to 75 minus 0.5 V1 you will get. Okay. Yes, now I got two expressions, function of I and V1. So I'll do one thing. So let me replace this I, that's a equation number 2. So I'll replace in equation 2 the I which we obtained in the equation 1. Okay, so this is I, this is also I, so 1 must be equal to 2. Both the left hands, both are having same left hand side. Okay, so I'll use this for the verification. So what is known now is this. So I is equal to one equation is V1 by 8 kilo ohm. Another equation is I is equal to, that is 75 volt minus 0.5 times V1 divided by, let me check that number and equation as well. So 75 minus 0.5 V1 by 2 kilo ohm. Okay. Okay, by 2 kilo ohm. That's fine. Okay, so that there won't be any mistake later. Yes, you can equate 1 and 2. So then V1 by 8 kilo ohm is equal to, therefore we can conclude this way, 75 minus 0.5 V1 divided by 2 kilo ohms. So then 8K and 2K, I can make this as 4. So then I can write it as V1 is equal to 4 into 75, that is going to be 300. Keep it as in volts, then 4 into minus 0.5, it's going to be minus 2 V1. So as a result, I'll end up with 3 V1 is equal to 300 volts. Therefore, V1 is equal to 100 volts is the nearest integer. So I can feed the answer as 100. But let me have a small verification. Okay, so any circuit analysis demands a simple verification because we don't know where we committed even a small mistake. I got V1, that is 100 volt. Let me get back to the circuit and do a small verification. So this is 0, and you know this point is going to be 75 volts, and you got this potential as now how much? 100. Okay, V1 is equal to 100. So this potential difference is equal to 100. That means since bottom is 0, the top will be equal to 100 volts. Okay, what is the current I then? I is equal to 100 by 8. 100 by 8 will be, so 10 by 8, 1.25, so 12.5 milliamps. So the current in this branch will be 12.5 milliamps. That's fine. So okay, that is your current I. Okay, so this is the current I. So here also you are getting the same current I. Okay, we'll check whether this current is also going to be same 12 point. It has to be because this is given as I means this also same means this current magnitude should remain 12.5. Will prove it. Okay, so this point potential we know already 0. Off of 0.5, off of V1 100. So off of this will be equal to 50 volts. So 50 means this is also going to be 50. Okay, because it is 0, potential rises by 50. So that means the net drop across this is equal to how much? 25. 25 volt across 2K will make a current of, that is 8 current 12.5. It's balanced. So 12.5 comes in, 12.5 leaves, and nothing goes here. Or the current leaving here 0 milliamps. Here it is 12.5. What's coming here? 12.5 is coming here, and is also 12.5 conforming. So here it is 12.5, and here also it is 12.5. That's your loop current balanced. Okay, so that's a simple verification for the answer. So confidently we can give the answer as, okay, so it's a numerical answer type. So confidently we can say the answer is 100. Okay, that's relatively an interesting problem. So in the GATE electrical 2020 paper. Okay, yes. So we should not get surprised always by seeing the dependent sources. Strictly go by your basics of electric circuits, then you will connect instantly. So but still it's easy, not a tougher one. Okay, so thanks for watching, and do subscribe the channel. Okay, we'll update you with the next problem.